Good evening, everyone. So, my name is Samir Kumar Singh, and I am PhD scholar. Currently, I'm pursuing a PhD in IT Robot. I'm third year PhD students. So, today we will discuss the week 2 tutorials, and there we will take some questions and that will help you to solve the problem of the week 2 assignments. So, that is the question number one. The question is the signal sync VT has the Fourier transform. Basically, we have to calculate their Fourier transform of sync VT. So, please try this. And we have four options, and I will discuss the answer to these questions after a few times, so you guys can try. Again, I am repeating. The question is the signal sync VT has the Fourier transform. So I will give 1 minute. Try this. That is basically use the Fourier formula of the Fourier transform. That signal is given in time domain. You have to calculate what will be the Fourier transform of sync VT. Last time I am repeating. The question is a single signal sync VT has the Fourier transform. So right option of this question is the B part. The answer will be 1 by B for f from y is minus b2 minus b by 2 to plus b by 2, and it will be 0. Basically, when we took the Fourier transform of the sync function time domain, it, the answer will become as a a rect function in the Fourier domain, Fourier transform in frequency domain. So that is the solution of these questions. Basically, the general signal for the general signal, that is a B sync VT has the Fourier transform 1 from minus b by 2 to plus b by 2 and 0 otherwise. So here we have to calculate the Fourier transform sync VT. So B will come on the right hand side and it will become 1 by B. So it will be 1 by B for f that will become sorry that will go from minus b by 2 to plus b by 2, and it will be 0 from the otherwise. So answer will be a B part. So question number two is, and the question number two is the considered system with the input xt that gives the output yt. Okay, if the system is time invariant, given the input x t plus t naught, the corresponding output is. So in this question, we have input signal xt and we are getting the outputs yt, and the condition is given that that is a time invariant. Okay, so they are asking if now we are giving the input is xt plus t naught. So there we have to calculate the corresponding output of the this signal. So I will give you 2 minutes to solve these questions. After that, we will go for the solution. So everyone try these questions. That is, this question belong to the properties of the signal system. Question is on your screen. So I am again repeating this question. Consider a system with input xt that gives output yt. For input xt, we are getting the output yt. And if the system is time invariant, that is condition, given the input xt plus t naught, here input is shifted by the t naught, then the corresponding output is. If anyone have doubt this in questions, they can ask. So everyone try these questions, and this will help you to solve the assignments. So now we will go for the answer, and answer will be C part. So that is the explanation of the question. So actually, what is the time invariant? Time invariant means actually what is time variant which vary with the time, but here in time invariant means it will not vary. So yeah, there is given that we have a input xt, then we are getting the output yt. A condition is given is a time invariant. This minute if we say we shift if we are doing the shifting in input signal by t naught, then we definitely we will get whatever we get the output in, we will get shifting our t naught at the output signal. So right, it will become xt plus t naught, because there we are shifting the input t plus shifting the input to t by t by t naught. So on the corresponding output we will get the That is answer. So that's the question number three. Question number three is consider two signal xt and yt, and we have to find out the uh, if we convolve the xt with the y minus t, that is the y minus t given as. So we have to find what will be the answer if we did a convolution of the this signal, then what we will get as the output. The signal actually there. What is significance of these terms? Again, I will wait for the 2 minutes. So try these questions. Try the question number three. After 2 minutes, we will go for the solution and the explanation. If anyone have doubt, you can ask. Again, I am repeating this question number three, and the question is: consider two signal xt and yt. Then the signal xt convolved with y minus t given as. So what will be the output of this question? So answer of the discussion is B part. So we can write that xt by t by tau minus t dt, and we will integrate both the term from minus infinite to plus infinite. That is the explanation. That's okay. So we can write the xt convolved with convolution with yt directly in the form of minus infinity to infinity, and will become x tau into yt minus tau. But here we shift the t by the minus t. So here we will write the minus sign outside, and will become t minus tau. So after few mathematics, it will become capital tau minus t. Sorry, small tau minus t. The answer will be like that. So B part is the right answer. Actually, there we are doing the multiplication convolution is time domain convolving. So we will do the integration of these two terms. We can write this term in this form. Next, question number four. Question number four is: if MT has a Fourier transform capital MF, the Fourier transform of MT sine 2 pi FCT is. This is the property. There we are checking the property of the Fourier transform. So there we have an input signal MT, the time domain. We are getting the Fourier transform as a MF. When we multiplying the sine 2 pi FCT in input term, so what will be the output? The Fourier transform. So actually we have to. So please try this. We have four options, and again I will share the solution and explanation after 2 to 3 minutes. Please try. Again, I'm repeating this question. We have a, if MT has a Fourier transform FF, the Fourier transform of MT sine 2 by FCT is. There we have to calculate a Fourier transform this term. So here I'm giving the hint. You can break this term in form of exponential term and just apply the property of that term. So answer will be a C part. Okay, because in two terms is coming, because when we break the sine 2 by FCT, it will break in the two terms, e to power j2 by FCT minus e to power j2 by FCT upon 2j. So that's why we are getting two terms, and that is the explanation of this question. Where MT as a Fourier transform here as a Fourier transform NF, then the Fourier transform MT is the sine MT Fourier transform of MT sine 2 by FCT is become that term. It's showing right shifting, it's showing the left shifting. So overall our MT terms is shifted two part. Now question number 5, that is also related with the last one. Just general question. Question is, let xf denote the Fourier transform of the signal xt. The Fourier transform of the xt e to power minus j 2 pi fct. Here we are multiplying these terms in the time domain. Then we have to calculate what will be Fourier transform. Initially we have input signal xt and getting the Fourier transform xf. Now we are multiplying these terms. Then what would be the output? We have four options. Sorry, that is typed by mistakenly. So please don't consider this packet. Again, in question option B and D, please don't consider. It will be xf into e to power minus j2 by fc. Similarly, that will be xf e to power j2 by fc. Again, I will discuss this up to try this. Last 20 seconds. Please try this. The question is, we have to calculate the Fourier transform of this term. We have been multiplying the e to power minus j2 by fct with the xtc. So answer will be a part, because we are doing the shifting in time domain with the negative sign. So in positive in the frequency domain we got the shifting of the fc, and that is the explanation. Suppose if we shift with the plus fc, the answer will become x f minus fc. Okay, so there we are shifting with the minus fc, it become x in into frequency domain, it will shifted by the plus fc. If we add both the term xt e to power minus j2 by fct plus xt into e to power plus j2 by fct, I multiply by 2, so e to power, both e to power terms become the cos. So here we will, it will become x f plus fc plus x f minus fc by 2. That's those sort of property formulations. Okay, next question number 6. The question is, let xif denote the Fourier transform of xit. I vary from the 1 to 2. Okay, it is varying. Then we have to calculate the integration of the x1t into x2t. It would be equal to, so we have to find out the output, and this limit going from minus infinity to plus infinity. Minus term is missing there, don't worry. Typing mistake, but I'm going from the minus infinity to plus infinity. Since then we will change on the on the on the PPT slides. I will go to the PPT, and I is varying from the 1 to t. Try this. I will explain this question after 2 minutes. We have two signal x1t and x2t. We have to calculate that what will be the value of this integration and their limit going from minus infinite to plus infinite. Please try. So answer will be C part. Okay, that is the explanation of this question. First of all, there I will correct it. It will be limit is from minus infinite to plus infinite. So that is the explanation. There one point is noted that x star x2 minus t star x2 star minus t as a Fourier transform. That is this is seen as follows. We can get from this, we have x2 minus t. We have to calculate the, whenever we calculate the Fourier transform, it will become, okay, here we are doing the conjugates. So x2 f become x2 star f, and e to power minus j2 by f d, and minus sign will replace with the plus, j minus j will replace with plus j. So that is also a new property, x1 tau x2 star tau minus t. We are getting the x1 f x2 star f df. Okay, again x1 tau into x2 star tau minus t would be equal to x1 f to x2 star to star f to e to power j2 by ft ftdf, because we are calculating inverse. So it become x1 f x2 star f e to power j2 by ft dot df, t is equal to 0. So it will become, if t will replace with 0, so it become 1. That will be, so Okay. So now we have question number 7. The question number 7 is, let the xf is the Fourier transform of xt, the Fourier transform of the xt. Again, I'm repeating the question. Xf is the Fourier transform of xt, the Fourier transform of the signal xt would be. As we know, we generally we read that xt have a Fourier transform xf. Okay, here is given that xf has the Fourier transform of xt, so we have to calculate the Fourier transform of signal xt. Please try this. If anyone have doubt, this question can ask or can comment. So answer will be x to power x minus f. You can solve this question by the duality property. Okay. So that is the explanation of this question. The question is, given xf is the Fourier transform xt, and we have to calculate the Fourier transform capital xt. That will come out x2 minus f. Just follow the duality possibility. Actually, there we have to calculate as x. It will be capital. So xf is the Fourier transform xt. We have to calculate as xt, and that will become x minus f. Next, we have question, theoretical question. The question is, Fourier transform is best suited for the analysis of four options. First is the continuous time aperiodic signal, discrete time periodic signal, continuous time periodic signals, discrete time aperiodic signals. Question: the Fourier transform is best suited for the analysis of. I will wait for 1 minute. Try this. In the last session, we discussed about the Fourier series, where question was the Fourier series is best suited for the analysis of. Here we are talking about the Fourier transform. Fourier transform is best suited for the analysis of. We have four options: continuous time aperiodic signal, discrete time periodic signal, continuous time periodic signal, and discrete time aperiodic signal. So here, as here we the question was, Fourier transform is best suited for the analysis of, the answer will be continuous time of periodic signal. Actually, in Fourier series, we are find the Fourier series for the periodic signal. Here for the Fourier transform, we are to calculate a Fourier transform. By basically consider the periodic signals. Okay, answer will be a part. That is the explanation solution of the question number 8, and answer will be a part continuous time of periodic signals. Next, we have the middle question. The question is, consider a signal xt that is equal to 1 by 2 sinc 2t, where sinc x is equal to sine pi x upon pi. The Fourier of transform of the signal is. That question is related to, I think, it was first question. Okay, we have sinc function, and we have to calculate the Fourier transform of the signal. We have sinc function in a time domain. So Fourier transform. What will be the Fourier transform of this signal? As for a hint, I tell you, sinc function in time domain, generally in Fourier transform, in Fourier frequency domain, we get in that pulse. So we have four options. So try this question. That is a good. That is a good question. Take 2 minutes. After that, we go for the solution. Again, I am repeating this question. Question: consider a signal xt that is equal to 1 upon 2 sin 2t, where we can write the sinc function as the like sinc function equal to sine pi by x upon pi x. So we have to calculate a Fourier transform of this signal. So that is the question. We have to calculate the Fourier transform of the sinc function. That will be sinc 2t. We can write the sinc function. Sinc x is equal to sine pi by x and pi x. 1 by 2 represent amplitude, and that is shifting in the time domain. We scale that t with the 2t. There we are at the scaling. We are doing the scaling. So please find the Fourier transform of signal. So answer will be V part, and because okay, so that is the explanation. Generally, as we know, f sync ft has a Fourier transform of equal to 1. That will from the minus f by 2 to plus f by 2. Otherwise, it will become 0. So there f become 2 sync 2 by 2t. Okay, but so here time we change the amplitude. It become 1 by 2 and 2t. And the Fourier transform become 1 by 4 v2f, because if 2 sync 2t as a Fourier transform 1 3 by 2, b2if. So then our 1 by 2 sync 2t will become 1 by 4 b2f, and the limit go from the -1 to 1. Okay, and become 0 for the otherwise. So according to answer, we have a delta function from -1 to 1 and having an amplitude of 1 by 4. Okay, so that is the question number 10. The question number 10 is the let f accept the node of Fourier transform the signal xt. The Fourier transform its autocorrelation is. So this symbol represent the autocorrelation, as the tell us autocorrelation cross correlation. So we have to calculate the autocorrelation of the xt, and the time domain what would be the autocorrelation of xt. So I'm giving you 2 minutes. Please try this. Except denote the Fourier transform the signal xt. The Fourier transform with autocorrelation. Again, I'm repeating. Let accept denote the Fourier transform the signal xt. The Fourier transform with autocorrelation. There we have to calculate the autocorrelation. Okay. So answer of this question is B part, and actually in autocorrelation we will select the relation uh, of the same signal. So it will become the multiplication, and with that one is the mod x f square. So answer will be B part. Okay. Now in this session from this class, I'm adding the few MATLAB codes that will help you out. Okay. So first we will see the MATLAB code for the delta pulse, how we can generate in. Okay, as we know the delta pulse will at a t by it will be just for at t is equal to 0, and other points it will become, so it will lie at t is equal to 0. At t is equal to 0 the value will be 1, and otherwise it will be non-zero. Okay, sorry, it will 0. So for that is this is the basic code. So first of all, this is a screen of for the MATLAB. So this three is the basic command. So basically CLC command we use for the clear the command window. What is the command window? That part is represented in the command window. That is the workspace. Okay. So first of all I will run this code. After that I will tell you. So okay, just there we are running the code, and that is the result. First I will cut it. Okay. So you can get whatever input you are giving, yeah, whatever output, whatever variable you assign, you are getting that output in. What output is actually here we assign two input I and u, that is a single parameter. So what value it's contained and what the line, what value is lying, how much, what is the size of I and what is the u. We can see it on the workspace. Okay, that is called the workspace, and that is the command window. Okay, so first we are using the CLC. CLC that clear the command window. So what we can do, what, any calculation, just suppose we want to do 2 plus 3. Okay, so we are getting the 5. Okay, that's the 5. So if you want to clear the command window, okay, so just type the CLC. So CLC is used to clear the command window. Okay, if you type and to clear the workspace, we assign the clear all. If we type the clear all, it will clear the workspace. So there we are doing. So it's clear the workspace, and close all use the close the previous figures. Whatever we run in the previous codes, and we are getting the output whenever we type the close figures, the command window, automatically our figures, last figures will be closed. So okay, so there we are generating delta signals. As we all know about the delta pulse, it will be just general data pulse at t is equal to 0, and at t is equal to 0 it will become 1, and otherwise it will be non-zero. So to generate a delta pulse, okay, we consider a few input signal, that is the u, that is I. We are taking time interval from the -5 to 5 plus 5, where the time is with a gap of 0.1. So if we run this, first we'll cut it. Okay, so you can see there, minus from the -5 to 5, with the spacing of the 0.1, we are getting the 101 values. Okay, so we consider the consider input matrix. It's showing our time interval, so we can check there, check the value of i's, what value, the size of this I, it's 1 cross 101. Okay, so we can check that. Sorry. Okay, so we take the gap of the 0.1, -5, -4.94 meter, -4.8, 4.7. Okay, so we are there, we consider time interval, because we have to representing the delta pulse in the x-axis. Generally we in the x-axis we represent the time interval, so that is shown by the I. Okay, okay, as we know, delta pulse come the ones at the point of t is equal to 1, okay, t is equal to 0, otherwise it will become 0 generally. So we we consider the 101 time interval, and it will come 1 at t is equal to 0. Okay, and other values it will be non-zero. Sorry, t, sorry, at t is equal to 0 it come 1, otherwise it is 0. So from 0 to around -5 to 0, it's 0, this matrix becomes 0, and it's coming 1 at the 0, and for the rest point again we consider 0. It's showing you the input matrix that will represent a delta pulse. So for in, okay, the first 50 values it will become 0. Okay, -5 to 0 it will come out 0, and at the 51 points, as we consider it 0 here, this value will be represented by the 51 points, and rest from 52 to 50, 52 to 101 it will come 0. So that we represent that. Okay, now we have to plot, to draw the multiple plot. We are using the subplots, because I will there I will show the two result. So basically subplot has been subplot function has been represented by this term. So there as significance of x is the representer. Actually the x represent a row, y represent a column, and z represent the plot number. Okay, because there we consider the multiple inputs, multiple plots. So sub 2 1 1 mean 2 is the represent a row, its mean we having a two row, I mean first row, second row. That is a column, right? First column, second column, third column. First row, second row, third row. So two is two shows number of row, first row, second row. Okay. There we have one column. Second, first row, second row, but we have a one column. Okay. So subplot one represent the plot number. 2 1 1 second row, first second row. We have the two. We have two row, first row, second row, first column, and first value, and that will represent the second value. Second row, first column, and second value. Okay. So here we plotting the, okay, in the continuous domain, and if we have to plot the delta n in time domain, in discrete domain, to plot a discrete domain, we are using the stem. Okay, stem represent the, so we there is run the codes. Okay, so that first plot, we have two row. Okay, first row two row, subplot 2 1 1 2 1 1 second row, we have two rows, first column, two row one column, two row one column. The first plot, two row, second two row, first column, and second plot. It's representing a continuous delta pulse. Okay, that will come one. In a discrete domain, we have 101 points. At a 0, it will become 1, otherwise it's not, it's 0. At a 0 point, or delta plus showing 1, otherwise that is representing a delta n term. Okay, and this is representing the delta t term. So this was the first code, and explanation of this has been shown in the PDF. So that is the basic codes. Okay, if you have any doubts, you can ask. So with the help of this code, you can generate delta n plus 5, delta n minus 5, whatever you want. You can add two delta signals, you can subtract two delta signals, you can take the overview of the whole delta pulse. Okay, if you have any doubt, you can mail me. That is the result. You can try and plot this on your MATLAB. Okay, now so next code is the unit step signals. So there will plot the MATLAB code for the unit step signal. As we know, unit step means it's from minus infinity to 0, it becomes 0, but from 0 to infinity it becomes 1. Okay, that is a unit step. That basically represents UT, or UT in continuous time domain, and UN in the in discrete time domain. So this is the basic code. Okay, so then we will go for the MATLAB. That is to test. So so here we can see the advantages of the using of these basic commands. Suppose we can come, if we not use these basic commands to see, then see what we have to face. We recommend that these three commands, these terms, CLC, close and clear, and we are using our new code. So if we will not use these codes, so we will see what we will get the uses. So there we run this. Okay, so it's also so it taking the previous value also. It also store the previous value in works. Suppose we have IIT, because we are not using the basic command, we are getting the data of the previous code in the command window. So advantage of these terms, it will be, it will delete the previous code, the data of the previous, will not consider the previous data. So okay, so now we active these three terms, CLC, close on, clear. So it will be clear the previous values. CLC will clear the command window, close all will clear all the previous figures, but close the figures, and clear all will be clear the workspace. Okay, so we will after few times. Okay, so there we have to generate the unit impulses. Sorry, unit step signals. As I told you, unit step mean it will be 1 from 0 to infinity, from minus infinity to 0, it will be 0. We have to plot ut. So here we have plot ut plus 1, ut and ut minus 1. Ut plus 1 means first signal becoming 1 from the minus 1 to infinity, otherwise it's 0. Ut means it become 1 from 0 to infinity, and ut minus 1 it becomes from 1 to infinity. Okay, so we have a few time interval minus 2 to 2. Okay, and with the time with a gap of 0.01. So overall we are getting the 401 values. Okay, you can increase the sums or you can decrease the sums. This is a basic time interval. So okay, so we have to plot a ut plus 1. The significance of the t plus 1 ut plus 1, it will be 1 from minus infinity minus 1 to infinity, otherwise it will become 0. So it will be 1 from t greater than equal to the minus 1. Similarly ut it will be 1 from t greater than equal to 0, and it will ut minus 1 it will be 1 from t greater than 1. Actually we have to time we are plotting the signal from the minus 2 to 2, that having the 401 values. Initially it was 0 from all points. The this term significance previous significance, it will non-zero from minus 1. ut show it will non-zero from 0 to infinity, and it will non-zero from the 1 to 1 rest values. Okay, so we will there be plotting the ut plus 1, ut and ut minus 1. Again we have to draw the multiple plots. So again we are using the subplot function xyz. There x represent the row, y represent the columns, and z represent the plot number. Okay, so overall we are plotting the sixth plot. Okay, so what is the sixth one? Here we are representing the row. We have a six row, 1 2 3 4, 1 2 3 4 5 6, 6 row. Okay, 1 mean first column, 6 row, 1 2 3 4 5 6, column is 1 1. Okay, 6 1 1 6 1 1 6 1 2 6 1 3, because we are lying from the first 6 row and first column. So firstly we were plotting the ut plus 1 in continuous domain. Stem plot shows the un plus 1. It shows that there we plotting discrete signals. Similar, last two represent these two terms represent the ut in a continuous domain and a ut in discrete domain. And ut minus 1, un minus 1 represent the we are plotting in continuous domain and a discrete domain. Okay, so there we plot this six curve. So as you see, we are getting the 6 rows in one columns. So first curve showing the ut plus 1, that lying from the minus 1 to, because in the time domain we consider a time interval from the minus 2 to plus 2 with the space of 0.01. So it will be 1 from minus 1 to 2, and it will be 0 from minus 2 to 1. That is showing the continuous domain. Now we are plotting discrete domain. So it will be 1 from minus 1 at every particular interval from minus 1 to 2 with the space of the 0.01, and from this value minus 2 to 1 it will be non-zero. Similarly we have to plot the t ut, that means it will drop from the t greater than equal to from 0, it will be 1, otherwise no, it becomes 0. To generate a union discrete domain using the stem function, you can see in the MATLAB code. Here you plot, there you are using the stem. Okay, ut union in discrete domain. Next we have ut minus 1 signal in continuous domain. So its mean will become 1 from at a 1, otherwise 0 from minus 2 to minus 2 to 1 time interval, it will be 0. From 1 to 2 it's have it's the 1. Similarly, we draw the un minus 1 at a time domain as well discrete domain. It will be 1 from the 1 to 2, and for the rest of part it will be 0. So that is a code number 2. Okay, you can generate these signals in your MATLABs. That will help you a lot to make the simulation or for analyzing the result. Okay, just change the parameters. You can play with this. Suppose you as you can see when you are to decrease the time interval minus 1 2. Okay, and you want to plot from the 2. Okay, okay, sorry, yeah, we'll decrease the time domain and we consider on the minus 5 2. Okay, okay, so 2 1 minus 2. Okay, so it's mean it also will change plus 2. Okay, it will become minus 1. Okay, so okay, so there we change the time interval, and where they plotting for ut minus 2, ut minus 1 and ut plus 2. Okay, so now the code are same. Okay, so you are saying you're plotting t plus t minus 2. It's showing the 2 plus from the it's showing the 1, the magnitude, it's showing the 1 magnitude from the 2 to 5. So in time domain and in time in continuous domain and discrete. So there you are plotting a ut minus 2. Okay, ut minus 2. Here we are plotting the ut plus ut minus 1. Here we are plotting the ut plus 1. Don't go, we have to change there. Next we are going for the code number 3. So that is the code. You can change it. You can change this. Okay, that is the result. Okay, here we will add and subtract the two in step signals. So as and we see what we are getting. Okay, so again there we firstly we generate the unit step signals, and there we will do the addition and subtraction, and we'll see what type of output we are getting. Okay, again we initialize the team basic three basic commands: clc, close all, clear all. Again I'm repeating this, the working of this clc for the clear the command window. Okay, that is the command window, and close only used to the close the previous figures, clear only using to clear the workspace. Okay, that is the signal parameters. Again we are considering the interval from the minus 2 to plus 2 with a gap of the 0.01. So that they are using the three basic commands. First we will generate ut plus 1, ut and ut minus 1, and then we will see, and there we are performing the addition operation and subtraction operation. So for the addition we multiply the 2 the u1 and 3 u2, where un represent the ut plus 1 and u2 represent the ut. Okay, similarly we are applying a subtraction operation from the u1 between the u1 and u2. U1 represent the t plus 1 and ut represent the ut. Okay, Again, to draw the multiple result, we use the subplots. For a time domain, we use, sorry, we continue to the continuous domain, we will use plots, and for discrete domain, we will use step function. So we are 4 to 1, which means we have 4 rows, 2 columns, and first plot. Fourth row, 1, 2, 3, fourth, second column, first column, second column, fourth row, second column, okay, fourth row, second column, third plots. So that is the basics plots. So left side represent the discrete domains performance, and then that is a continuous domain. Here we consider two rows. The first is, that is the first row, that is the second row. Okay. So firstly we are generating the ut plus 1. So that is 1 from -1 to 2, and otherwise it will become 0. Next we generate a ut, that will be 1 from t equal greater than 0, otherwise it will be 0. So there you are performing the addition operation. So in the time domain, so we multiply the 2 ut plus 1. We multiply, so it's 1 will multiply by 2, and it will become 2. Next we plot that we multiply 3 in the second term, and 3 in the ut term, so it will replace by the 1 will become 3. Okay, so we have to plot the ut plus 1 plus 3 by 2, 3 2 plus 1. Okay, so when we addition of these two signals and we apply these operations, so we are getting the result. Okay, next we apply the subtraction operation in continuous domain. 4 we multiply the 4 in time, 4 in on this terms, and -2 in on that term, and overall when we conclude that plot becomes like that. Okay, similarly we think same things we applied in time domains, sorry, in discrete domains. Okay, that's showing the plot of un, sorry, that is showing the plot of un plus 1, it's un plus 1, and that's showing the plot of un, and then we're doing the multiplying of 2 with the un plus 1 and 3 the un terms. Okay, that's showing the addition of these two terms, that is showing the subtraction. So that was the broad explanation of these three MATLAB codes. So today we learn about the delta pulse, unit impulse, and addition of unit impulse, sorry, unit steps, unit addition and subtraction of unit steps. So from using these signals we can generate a functions delta function. Okay, so the main motive of the to add the MATLAB lesson to make the to have to teach you some concepts of the MATLAB coding. Okay, if it really help you, please tell me. We can change or we can go for the whole session for the question session if it's not okay. So again, so that is over from my side. Thank you. You can try these plots on your own on MATLAB. Okay. Thank you. Thank you.